Welcome to this lecture for Inf 1B. This lecture is about conditionals and loops. As always, I'm adapting a set of slides which has been worked on by a large number of people, and this one in particular drew quite heavily on a set of slides that went with a book by Sedgwick and Wayne, which a long time ago used to be the course book for this course. These days we use the Java tutorial as our major course book, but the Sedgwick and Wayne book is still of considerable interest. You might like to have a look at it, and in fact if you search you will find that they still make available slides which have diverged quite a long way from this set, but which might be of interest to you if you would like a slightly more detailed view or simply a different view from what you get here. So anyway, that's worth knowing. So let's start with conditional statements. What do we mean by this? We're talking about control flow here, so we're talking about how one manages which statement in your program should be executed after which other statements. So when we talk about control flow, what we mean is a sequence of statements that are actually executed in a program. Like here, you've got statement 1, then statement 2, then statement 3, then statement 4. Sometimes we need something more complicated than that in order to get the behaviour that we want of our program, and that's when we use conditionals and indeed loops. So here on the right we have a more complicated example, and let me just read through this just to check we're on the same page about what it means. We are here testing boolean 1 if, so a boolean is just a type which can be either true or false, so we might have a complicated expression which, depending on the current state of the program, when we evaluated it, might evaluate either to true or to false. If it evaluates to true, then we go left, we go to statement 1, thence to statement 3. If, on the other hand, it evaluates to false, then we take the vertical branch that labelled false and we go down to test boolean 2. Now if boolean 2 is true, then we go to statement 2, and then we go back and retest boolean 2, because the idea is it might have changed as a result of something that we did in statement 2. If boolean 2 is false, then we go down to statement 3, the same statement that we could have reached if boolean 1 had been true in the first place. So this is a fairly typical representation of the kind of control flow that you might have in a program. So to start with an if statement, also known as a conditional statement, what do? We evaluate a Boolean expression e. If it's true, we execute some statements, and if it's false, we execute some other statements. And so we sometimes call the set of statements that is executed if the value of e is true the if block, the if part, and the other set of statements that's executed if e turns out to be false, we call that the else part, or the else block in Java. Here's how it looks in Java. What is there to know about this? Well, we use the keyword if. The Boolean expression must be surrounded by brackets, round brackets like that. That's one thing to know. And then both the if block and the else block are surrounded by curly brackets, as is usual for surrounding all kinds of blocks in Java. And we also have the other keyword else. The else keyword can be omitted if you don't want to if you don't want anything at all to happen if the statement is true. So here's a tiny example. Little exercise for you at the moment. What does this block down the bottom actually do? What we're doing is we're testing whether x is greater than y. X and y here had better be two previously assigned variables, probably they're going to be integers. And if x is greater than y, then we're going to execute the sequence of statements inside the curly brackets there. On this occasion there are 3 such statements. The first one declares and initializes a new integer variable called t. It initializes it to the current value of x. Then it sets the value of x to be the current value of y. Notice that that has no effect upon t. So t is at that point the old value of x, and the new value of x is the old value of y. And finally we set the new value of y to be the value of t. So you've probably got it already. What we're doing is we are swapping the values of x and y using a temporary variable t in the case that x is greater than y. So we want to end up in the situation where x is less than or equal to y. If statements or conditional statements are also sometimes called branching structures, and you can see why that is by looking at the shape of the control flow graph that you get here. We've got trees always grow upside down in computer science for some reason, so you should think of this blob at the top as being the root of the tree. We go into a Boolean expression and we might go left if it's true or right if it's false, and then we go to some statement T or to some statement F, depending on that. All very easy. Let's look at a couple of examples. So on the left we are saying if x is less than 0, we would like to set x to be minus x. Now you might say, how can you possibly set x to be minus x? How can x be both itself and minus itself at the same time if it's not 0? But remember, this is imperative programming, and so what's happening here is that we are evaluating the right-hand side of that equal statement, of that assignment statement, which is what it is, using the pre-existing value of x. And then, because of the way assignment works, the value that that right-hand side evaluates to becomes the new value of x. So in other words, what we're saying is if x is less than 0, perhaps it's minus 7, then we evaluate the right-hand side of the assignment statement, which gives us minus 7 or 7, and then the assignment statement as a whole sets x to be 7. So the overall effect is that x was previously minus 7 and now it is plus 7. So we're negating it if negative. That's a useful thing to do. On the right hand side we are saying if x is greater than y, then max, which had better be a previously declared variable, is going to be set equal to x, and otherwise max is going to be set equal to y. In other words, max is going to turn out to be whichever is greater of x and y. And that's how it's represented graphically. So, some examples. We have seen the first 3 of these already on previous slides, so we're going to find the absolute value of a variable x in the one-liner at the top. We put them in ascending order by swapping them using a temporary variable in the second example. We find their maximum and assign the maximum of x and y to be the new value of a previously declared variable max in the third example. The fourth example is the only one we haven't yet seen, and it is not really any harder. We're going to say if den, that's standing for denominator, and incidentally I might argue that denominator would have been a better name for that variable. If the denominator is equal to 0, notice the fact that we have to use the double equals sign here, because that isn't an assignment statement in the if there. That is a Boolean expression being evaluated, so it should evaluate to true if the denominator is 0 and to false if the denominator is not 0. So in this case, if it is true, we are going to print out division by 0, and if it's not true, then we're going to actually do a division sum. We're going to print the result quotient equals num, which is presumably some kind of numerator variable assigned previously, divided by that denominator, and we know that that's safe because we just checked that it wasn't 0. Remember, if we did try to divide by a 0 denominator, then we would get an exception raised at runtime, and presumably the idea of this program is that we don't want that to happen. So that's if statements. Let's go on now and think about loops, which are expressed using while statements in Java. So a while statement is a structure for expressing repetition when you want something to happen some number of times. So similarly to the if statement, you start off by evaluating a Boolean expression, and then if the Boolean expression comes out to be true, you execute some statements. But this time, when you get to the end of the block that follows the while keyword, you go back to the beginning of that block and re-evaluate the Boolean expression. And if it's true again, then you execute the block again, and so it goes on. And so you only fall out the bottom of the while loop and go on to whatever is the statement following the while loop once you get to a position where the Boolean expression is false. And here's how that looks graphically. And here's an example. Let's suppose that we would like to print the powers of 2 up to and including 2 to the n for some n. So how are we going to do this using a while loop? Well, we're going to use a loop counter. We're going to use a loop counter called I, that's an integer, which starts at 0 and it's going to go up by 1 each time through the loop until it gets to n, the maximum value that we want to be concerned with. And we're going to use another integer variable val, which starts off at 1, and we're going to double it each time, and that's how we're going to calculate the powers of 2. Incidentally, we're going to see a better way of doing this later on, but this is just our initial illustration of the while loop. While loops can be very useful. So, what's going to happen? We start off with I being 0. I've got that in the table of values at the right. And now we set val to be 1. And now we go into our while loop and we have to evaluate that Boolean condition. Well, is it true that I is less than or equal to n? Is it true that 0 is less than or equal to 1? Yes, it's true. So we're going to enter the block that follows the while keyword and carry out those 3 statements. And the result is going to be that we're going to print out I, and then a space, and then val, giving us 0 and then 1. Now we're going to add 1 to I, making it 1, and we're going to double val, making it 2. We're going to go back and test the Boolean condition again. It's still true that I is less than or equal to n, because 1 is indeed less than or equal to 2. And so we go through again, and we print out 1 and 2. And so it goes on, time after time after time, until we get to the point where we have set I to be 7 and val to be 128. At that point, when we check whether I, 7, is less than or equal to n, 6, we find the answer is false. And so this time we don't go through the loop again. We jump to the end curly bracket and we go on to whatever follows that in the program. When we wrap this up in a Java program, in order to do that, we have to put that fragment of code that we saw inside a method, inside a class. So what we've got here is a class which we've just called for convenience powers of 2, and we've put it inside the main method. Remember that standard Java main method, which always has to have this particular form, public static void main, taking a string array args as its argument, although in this case we are only going to want the first element of the args array, which we are going to call n. So what we're doing in that line there, you see, is we are saying we're going to take the 0th element of the array args. We're going to talk about arrays next time, so don't worry about that too much at the moment, but the result is that the value passed to that parseInt method is going to be whatever the string argument that was put first on the command line is. In the example down the bottom, that's going to be the string containing just the character 3. And then the integer.parseInt method takes that string, which just contains the character 3, and turns it into an integer 3, which is then assigned to be the value of the int n. Okay? And then we've got the code just as we saw it before. Okay? And so then the result is that if we invoke this main method of the powers of 2 class at the command line in the usual way by going java powers of 2 with the argument 3, what's going to happen is we're going to get the powers of 2 up to and including 2 to the power 3 printed out. Now here's a challenge. What about this version? It's very subtly different. Can you immediately see what's wrong with it? The answer is that there is indeed something wrong with it. If not, pause the video now and look harder until you do see it. Are you back? There was a missing curly bracket. This kind of thing is easy to get confused about, because if you typed that program in to your file and compiled it with the Java compiler, it would compile perfectly fine, but it wouldn't do what you expected. Because if you have no curly brackets surrounding the block after your while keyword, and the same is true of if and else, then the effect is that only the first statement is considered to be that block. It's considered to be within that block. So if you like, there are 2 versions of a while statement, one of which surrounds the block with curly brackets, so you get a whole collection of statements executed, and the other of which has no curly brackets and just takes a single statement, which is occasionally useful. But in this case, the result is that we will never actually change the value of I, and so that while loop will go round forever, just printing out 0, 1 forever, which is certainly not what you wanted. If it ever came out of that loop, which it won't, then it would go on to the I equals I plus 1 statement, because that's not part of the block of the while loop. Okay, so this kind of mistake is easy to make, and although it can sometimes be useful to have a while loop or an if statement, indeed with only one statement, no curly brackets, the way to avoid making this kind of mistake is always to use curly brackets, even if they only surround a single statement. Why? The reason is because if you initially write an if or a while where what needs to be done is just a single statement, and then you at a later date or somebody else realise that actually you need a second statement, it's terribly easy to put in the second statement and not realise that at this point you also needed to add a pair of curly brackets in order to get the behaviour you want. A thing you'll definitely need to know when you're playing around with programs is what happens if your program accidentally gets into an infinite loop. If you're using an IDE, there's probably a button you can press to stop the execution. If you're running your program at the command line in Linux or indeed in Windows, then you hit Control-C. This is a good moment also to mention the increment operator, which is handy in this kind of situation. Our original program wrote I equals I plus 1. Now remember what that's doing. We're evaluating the right hand side using the old value of I, so the right hand side evaluates to 1 more than the old value of I, and then the assignment statement makes that be the new value of I. In other words, it increases the value of I by 1 from whatever it was before. And there's a piece of shorthand, we say sometimes syntactic sugar, because this slightly shorter version I++ is completely equivalent to the longer version I equals I plus 1. It's just there as a convenient other way to write it. So you can write I++ instead of writing I equals I plus 1, and experienced programmers usually would. And in fact, there are many variants, there are many similar shorthand operators in Java. We are really only going to talk about this one, but you might like to look into your Java textbook or the documentation for the language and explore the others. So challenge is, what could you replace the val line for by similarly? So that's our new program. Does exactly the same. It means exactly the same thing. Right, now, next we're going to look at for loops. Now, for loops are loops just like while. They are in some ways a little bit less flexible than while, so you might wonder, why are we ever going to use them? Well, as so often in programming, you'll come across this again and again, they are slightly less flexible. That tends to mean they're a little safer, that is to say, easier to get right and harder to make mistakes with. So in fact, you will probably want to use for loops more often than you use while loops. You should typically only use a while loop when there's some reason why you can't express what you want to do using a for loop. How do for loops work? We have an initialization statement, we evaluate a Boolean expression, and then it's familiar. If it's true, we execute some statements. Then we execute an increment statement, which has a special status within the for loop. And then we repeat. We go back to re-evaluating the Boolean expression to see if it's true. Here's how it looks in Java. We have, this is sometimes called a 3-part for loop. So we have init, Boolean expression, increment. What actually happens? We go in, we evaluate the init statement, then we check whether the Boolean expression is true. If the Boolean expression is false, then as with the while loop, we just jump over the whole block and go on to whatever follows the for loop. If the Boolean expression is true, then we go inside the block and execute its content, statement 1 and statement 2 in this case. And finally, before we do anything else, we execute the increment statement, the increment part of the 3-part for loop. Having done that, we go and evaluate the Boolean expression again and see whether it's still true. Here is a small example, again drawing on our powers of 2 case. We, in this case, are going to use a val which has been initialized outside the for loop. That's because we want just one val which is going to get replaced by a new value each time we go around the loop, rather than wanting a different version of the val variable each time around the loop. So this is a very typical example of a three-part for loop. We have int I equals 0, which is declaring and initializing a variable which we call a loop control variable. This is the one which is going to count how many times we've been around the loop and get incremented each time. Then the loop continuation condition, the Boolean expression in the middle, is going to check whether the loop control variable has or has not reached a certain bound. Now this is a capital N here. Now remember that typically speaking the names of variables in Java start with lowercase letters, so I would normally expect that to be a lowercase n. We're going to talk in a lecture or two's time about a special case where one might have variables starting with capital letters. But the point to be aware of at this point is that when your variables start with a capital letter, it actually has a particular meaning to experienced Java programs. They will expect something to be true of your variables if you write them in capitals. So generally speaking, don't start them with lowercase letters. Okay. And then our increment loop variable, and this is extremely typical, is just going to go I++, in other words, add 1 to the current value of I. The loop body is just our two statements. We're going to print out the current value of I, of the loop control variable, and also val. And then we are going to double the value of val before we go back and increment the loop variable and check whether it's less than or equal to n. So you can see this program actually does exactly the same thing that we saw in the while loop version. It's going to print out the indices and the corresponding powers of 2 up to our value n, that is where we want to stop. And here it is again. Let's walk through it. So we set val to be 1, I goes in and is initialized to 0. Is it less than or equal to n? Yes. Output 0 and 1. Now we're going to go through again, just like we did before. Each time we are just we're incrementing the value of I and rechecking the Boolean condition, and it goes on just like it did in the while version until we're going through the loop now for the last time, although we don't yet know it's the last time. So we checked whether 6 was less than or equal to 6, and it is. And so we print out 6 and 64, and then we double val, getting 128, and we then execute the increment part of the three-part for loop, getting I to be 7. And so this time when we check whether I is less than or equal to n, the answer is no, it's not. And so now we've finished, we jump over the loop and go on to whatever comes next. So when should you use while and when should you use for? So I already said you should use for if you can, and you should only use while if you can't. Why might you not be able to use for? Well, in order to be able to write a for loop, we had to be able to write a conditional statement based on a loop variable that was going to express when we should come out of the loop. Whereas in our while loop, we could write anything we liked in our while control Boolean expression. It didn't have to have anything to do with a loop variable, and it certainly didn't have to have that form. Yes, nah. Is it really true that while is less flexible? Actually, it's not strictly speaking true in Java. What is true is that it's generally easier to look at a three-part for statement and understand how many times you're going to go through it and when you're going to come out of it, which means that you are, in practice, less likely to accidentally write an infinite loop if you use a for loop than you are if you use a while loop. It's easier to make that mistake of writing accidentally an infinite loop using while than it is using for. And that's why I say, in general, if you have a choice, use a for loop. And I will stop there.